Okay, so let's look at question number 6. The daily takings, $X for a shop were noted on 30 randomly chosen days, full stop. The takings are summarized by summation x equals to 31,500. Summation x equals x squared equals to 33141816. Okay. First question, calculate unbiased estimates of the population mean and variance of the shop's daily takings. Second question, calculate a 98% confidence interval for the mean daily takings. The mean daily takings for a random sample of n days is found. Estimate the value of n for which it is approximately 95% certain that the sample mean does not differ from the population mean by more than $6. In this question, we are given n equals to 30, sigma x equals to 31,500, and summation x equals to 33141816. Okay, so that's around 33,141,816. So the first question is simply to find the variance, right? Unbiased estimate of the variance. So it's no doubt that you simply have to use the formula only. The mean doesn't change, right? Mean is the same for the sample as well. So that's just summation x over n. And sigma square is just 1 over n minus 1 bracket summation x square minus summation x square by n. So this is the unbiased estimate for the variance. So if you have the sample to be 30, then 30 minus 1 is 29. And just putting these values here, you get the answer. Okay, so then you get your answer to be 2304 for the first question. Okay, now let's look at the second question now. The second question is simply asking us to find the 98% confidence interval. Okay, so we are given the variable x, which follows a normal distribution with mean 1050 and variance as 2304. And we're trying to find the confidence interval, 98% confidence interval. But I want to find the value of c such that the probability is 99%. Now, why are we doing this? Let's have a look at it. So, if I draw a normal distribution graph like this, I want to find the 98% confidence interval. So that means I want to find the values of A and C such that this area here is 98%. Right? So 98% means the area in terms of probability is 0.98. Okay, so because this is a 98%, we know that the remaining area here and here includes 2%. So we get by symmetry, we know that this is 1% and this is 1%, right? So if we add 1% to this 98 here, it'll give us a probability of x less than c, so which is equals to 0.99, right? Because I've assumed this to be c, so less than c is 0.99. And our duty here is to find the confidence interval, right? So a to c is our confidence interval. But if you can find c, then there's no problem in finding a, right? So this is just 1050 here. So then, as you can see here, if you standardize, so this is a standardized variable. So if you reduce it to a c variable here, we say that it's a standardized normal distribution variable here. So similarly, okay, now what you can do is pz is less than c minus 1050 divide by the standard deviation will give you this much, because if you inverse the 0.99 you get this one, right? Or in other words, pz is less than 2.3233 is 0.99 from the table. Now this implies c minus 1050 is this. You're comparing these two expression here, and this is the same as this. So if you look at this one, then c minus 1050 should be plus or minus 11.66. Why plus or minus, right? Because in this case, if you look at it solely from this expression, it should be only plus. Okay, so then you'll find the value of c. So therefore, c will be 1160. Okay, so this is in the 3 significant figure that you have found it to be 1160. Now, once you know the value of c, you can find the value of a, because now you know this gap, right? This is just c minus 1050, right? Because you know the value of c, you can find the interval, this one. This is just c minus 1050. So this interval and this interval is the same thing. So then the 98% confidence interval is just a comma c, right? So c is 1160, so a is just 1050 minus 11.66, which gives you 1040. Okay, so 1040 is the answer. So this is the 98% confidence interval for this question. In this third question, you have to estimate the value of n for which approximately 95% of the sample mean differ by $6, more than $6. Okay, so let us say it just means that the confidence interval here is 95%. Okay, again, if you want to draw it figuratively, you could simply draw a normal distribution curve Okay, you can simply draw a normal distribution curve and say that this is 95% here on the condition that it differs no more by $6. So it means that this out here, this is 95% area, or in terms of probability it's a 0.95, right? So if this is okay, and if you look at this one, this just becomes 1044, right? So this is your initial, this is the given question, okay, and you have to find the number of n for which this is true. So if I only take this value here, 1056, and if I say it's less than 1056, or value of x is less than 1056, then this area becomes 0.975, right? Because this is 95% and rest 5% goes here and here, so this is 2.5% and this is another 2.5%, right? So less than 1056 means you're adding up 95% to 2.5%. So less than includes everything here. So 95 plus 2.5 is 97.5. So in terms of probability, it becomes 0.975. So if you understand that, the problem is fairly simple to solve now. Probability x less than 1050 is 0.975. If you standardize it, okay, so this is again standardizing it. If you standardize it, you get probability of C is less than the normal thing here. But in this case, the variance will be sigma divided by root n, because you don't know what's root n. We do know what's sigma, but we don't know what is root n. Okay, so simplifying, we get PC is less than 6. Root n over sigma is this. So again, inverse of 0.975 is simply 1.96. So that's why probability of C less than 1.96 gives you this. Okay. Now, if you look at this, okay, because probability of C is less than, and that's why probability of C is less than 1.96 gives you this. If you compare both sides, you have this equals to this, right? So from solving it, you get n to be 246 days. So this is 3 significant figure.